Hello, 7th graders. We are in section 4.6, which covers absolute value equations and inequalities. You already know how to do equations. You already know how to do inequalities. We're now going to put them together, all within one problem. So, we're going to start with a basic review. So you don't need to write this down, but what I want you to do is just watch. So we have a number line with 0 in the middle. And we're going to go to 3 on both sides. Now we know that the distance from 0, from 3, would be 3 units. We also know from negative 3 to 0 would also be 3 units. So if I said this, the absolute value of what number would give me 3? Well, the absolute value of what number does give you 3? Well, it could be 3, or it could be negative 3. So this right here is the graph of the solutions of the absolute value of x equals 3. Because the value could be positive 3, it could also be negative 3. So in example number 1, I want you to solve the inequality. So we're going to start with the absolute value of what number plus 5 gives you 11. Well, the first thing you must always do, and please make sure you always do this, keyword always, is you isolate the absolute value. So in this case, we have to subtract 5 on both sides. We get the absolute value of x equals 6. But then the absolute value of what number gives you 6? Well, it could be 6. It could also be negative 6. If we plug or check both of those values, the absolute value of 6 is 6, plus 5 is 11, and the absolute value of negative 6 is 6 plus 5, which is 11. So it would work either way. So here's your rule, your key idea. To solve an equation in the form where you have an absolute value of a variable expression equals to b, where a represents that variable expression, but b has to be bigger than 0, make note of that, you can solve two separate equations of a equals b and a equals negative b. So if I gave you an example that represented that, example number 2, I want you to solve the absolute value of 2p plus 5 is equal to 11. Now, is the absolute value isolated? Is it by itself? Absolutely. So you have to write two equations. Remember, this whole thing represents your a up top. So we have to say a equals b, which here is 11, and then we can say negative b, which would be negative 11. So I could write 2p plus 5 equals positive 11, and 2p plus 5 equals negative 11. Now, you can solve each of these on your own. These are easy. So subtract 5, 2p equals 6, p equals 3. The other example would be subtract 5, 2p equals negative 16, and p equals negative 8. So the two values of p are 3 and negative 8. Example number 2, let's say we have 2 times the absolute value of x minus 1, and then plus 3 is equal to 7. Now, in this case, the absolute value is not by itself. So you have to get the absolute value by itself first. Step 1, we're going to subtract 3. So the absolute value of x minus 1 times 2 is going to be equal to 4. I then have to divide by 2 on both sides because that's a times 2. So then we get the absolute value of x minus 1 equals 2. I then write my two separate equations, which would give you x minus 1 equals 2 and x minus 1 equals negative 2. I solve each of them. I add 1, I add 1. My two answers would be x equals 3 and x equals negative 1. And we're going to call this 2b because I actually added one extra example in here after the video was finished. All right, example number 3. I want you to pause the video and write your two equations for this equation, the absolute value equation. So pause the video and write just two separate equations. So the two equations that you probably wrote were 3x minus 1 equals negative 11 and 3x minus 1 equals positive 11. Is that what you got? That's wrong. Why? Absolute values by itself. If you remember our rule, b, which is a negative 11, has to be greater than 0. Because this is absolute value. Absolute value must always be positive, which means absolute value cannot be equal to a negative number. Therefore, this is empty set or no solution, because absolute value cannot be equal to a 0. Now, the next part of this section is talking about absolute value inequalities. So, this is where it gets a little trickier. So we're going to write two number lines, and I do want you to write this down. Two number lines. And we're going to number these. I'm going to go up to 4. And I'll go up to 5. And let's do that on both of them. All right. Now, when we're writing inequalities as compound inequalities, so in the first one, I'm going to write the absolute value of n minus 1 is less than 3. In the second example, we're going to do the exact same inequality, except we're going to make it greater than 3. Now, here's what it means. The absolute value of n minus 1 is less than 3 means, or represents, all numbers whose distance from 1 is less than 3 units away. So 1 is obviously right here. 3 units away from 1 would be to 4 and negative 2. So we have 3 units. And we also have 3 units to 4. Now, when we're talking about 3 units away from 1, it says less than 3 units. That means my graph would have to be an open circle on negative 2, an open circle on 4, because we can't be exactly 3 units away, but we have to be less than 3 units away. So this would be within 3 units, and this would be within 3 units. So it would be anything between negative 2 and 4. Now let's look at our next example. We're still looking at 3 units away from 1, which is still going to give us from 2 or negative 2 to 4. But now, the absolute value of n minus 1 is greater than 3 represents all numbers whose distance from 1 is greater than 3 units. So greater does not mean equal to, so we still have our 4 and our negative 2 open circle. But now we have to have distances that are greater than 3 units. So we would shade outward. Notice, this is important, really important, that we have conjunctions and disjunctions here. This problem here represents a conjunction because it's an and problem. This example says that x or n, I used x, but it should be n. So x is less than negative 2, or x is greater than 4. Shade outward, that's going to be an or problem because we can't have something that satisfies both things. But this one is in between, so it's a conjunction, which is an and problem. So if you actually solve both of these, here's how it would look. The absolute value of n minus 1 is less than 3. That would give us n minus 1 is less than 3, and n minus 1 has to be greater than negative 3. We flip the inequality and we reverse the number. So if we solve these, that would be n is less than 4, and n is greater than negative 2, which is exactly what we have up here. If we did the second one, the absolute value of n minus 1 is greater than 3, that gives me n minus 1 is greater than 3, or n minus 1 is less than negative 3. If we solve them, we get the same answer that we got up here. Now I want you to make note of your key concept at the bottom of page 236. So if you have your book online, or if you have your book with you, you can open it up and look. It says this: to solve an inequality that looks like the absolute value of a is less than b, and once again, a is your variable expression, you can solve it as two different things. You can solve it as a is less than b and a is greater than negative b, or you can write it as this. You could write it as negative b is less than a, which is less than b. It's completely up to you. Now this is your less than, which is your conjunction, which is your and problem. If you have an or problem, the absolute value of a is greater than b, you could write it as a is greater than b, or a is less than negative b. So example number 4. Solve the absolute value of v minus 3 is greater than or equal to 4. So you could write that as v minus 3 is greater than or equal to 4, or make sure you have that or. If you don't, it's incomplete. V minus 3 is less than or equal to negative 4. We flip the inequality. And now you solve both of these. V is going to be greater than or equal to 7, or v is going to be less than or equal to negative 1. We graph these, and I'm going to make that a better graph. Negative 1, 0, 1, 2, 3, 4, 5, 6, 7. Since they're equal to, it's going to be a closed dot on negative 1 and 7. And since we're greater than 7 and less than negative 1, we shade outward. Now, believe it or not, there are many, many businesses that use inequalities and absolute value in manufacturing. So to maintain quality, a manufacturer actually sets limits for how much an item can vary from its specification. You can use an absolute value equation to model a control quality situation. So, for example, example number 4. The ideal diameter of a piston for one type of car engine is 90 millimeters. The actual diameter can vary from the ideal by at most 8 thousandths of a millimeter. Find the range of an acceptable diameter for the piston. So we want a range of diameters for the piston. So, first off, D, we're going to let D be the actual diameter of the piston. So D is the actual diameter. Now, what do we know about that? The diameter, if we subtract the actual diameter by 90, that's going to give us a difference. Now, if it's exactly 90, great. That's exactly where we want it. But if it's a little over or a little under, remember the difference has to be a positive, so that's why we have absolute value. If we subtract the 90 from the actual diameter, we want it to be within 0.008 millimeters. So within means we want it to be less than or equal to 0.008. Now if I write this as two separate inequalities, I can write it as d minus 90 is less than or equal to 0.008 within, this is an and problem, and d minus 90 could be greater than or equal to negative 0.008. So if we solve this, we add 90 on both sides. That would give me 90.008, and d is greater than or equal to 89.992. Now you can leave it like that, or we could write it as this. The diameter has to be less than or equal to 90.008, but greater than or equal to 89.992 millimeters. So that's how the inequality would look. It's within. Now, you may have not heard this before, but actually what this means is it's between or from 89.992 to 90.008 inclusive. Inclusive means it includes the ends. It's not necessarily between, because it can be exactly 89.992 and exactly 90.008 millimeters. And so we would say it's between 89.992 millimeters and 90.008 8 millimeters inclusive. So the inclusive would be the last thing you put. So I'll write that down. And that's how you could write it as your answer.